Hello everyone, this is Dr. Lennon, and in this section we continue with statistics. In particular, we're looking at ways of visualizing statistical data through things like frequency tables, bar graphs, histograms, pie charts, things like that. So probably most people have some experience with that. They're quite common visual tools, and let's go ahead and get started. So again, tables and graphs. Okay, so a frequency table is basically you've got a bunch of categories, and then you're counting the things in that category. It's very common. A lot of times what you'll do is, if you're going through an inventory, you'll have your categories. Maybe you're going through a car lot, and you've got red cars, blue cars, and white cars or something like that. And as you go through, you just put a tally mark in each box when you recognize the color of the car, and then you total the frequency. So the frequency is just a fancy word for a count. Yeah, so the second column is the frequency, which is basically just the count of each category that you're looking at. So the relative frequency is a percentage, and that's just the frequency from your category divided by the total number of things. So if you had 4 red cars in a lot with a total of 10 cars, you would have 4 over 10, 40% relative frequency. A cumulative frequency is a running total. So that's one way to think of that. So it's the number of data values in that category and all preceding categories. So if you had, 4 red cars, 2 blue cars, and 4 black cars, then if you went category by category, red, the cumulative frequency would be 4. If you went red and blue, the cumulative frequency of those two categories would be 4 plus 2, which would be 6. And if you did the cumulative frequency of red, blue, and black, it would be 4 plus 2 plus 4, giving the total amount 10. Okay, data types and binning. So qualitative data, the typically your bins or your categories that you're putting things into are relatively natural. Colors of car. A lot of times you organize things by, male and female or whatever categories you're looking at. You could go by model of a car. Cars just come to mind to me for some reason, but it could be typically any number of things. But in those categories, things arise quite naturally. You could look at animals and you could say, okay, you've got mammals, you've got fish, and you've got reptiles or something like that. So those would be categories of animals or something like that. So there's many ways to look at categories for qualitative data. When you look at quantitative data, it's another story because you've got things assorted by numbers. So typically what you do then is you partition certain intervals and you do the count. So you're kind of artificially creating intervals which are acting as your bins or categories to form your frequency table. So quantitative data represents counts or measurements. So you could one example could be the amount of rainfall in a given month, and if one is 1 and another one is 1.5 inches and another one is 0 inches, how are you going to do that? Well, you could say, okay, 0 to 0.5 inches is one category, 0.5 inches to 1 inch is another category, and so on. So you could kind of frame them as half-inch intervals, and then those would be acting as your bins. So if bin 1 was 0 to half an inch, and 1 month had 0.2, that would go in bin 1. And if another month had 0.4, that would still go in bin 1 because both observations would be in that interval, 0 to 0.5. Okay, so so grouping them or binning them or creating intervals is the way you do that with quantitative data. So you're kind of artificially creating your own categories, which arise more naturally in qualitative data. So classify each following type of data as either qualitative or quantitative. Brand name of shoes in a consumer survey. Well, that's qualitative. You might have Nike, Reebok, if you're looking at sport athletic shoes, Adidas, so on and so forth. But those are not intervals of numbers, so those wouldn't be like quantitative bins. Yeah, non-numerical, hence qualitative. Heights of students, that is something measured that gives a numerical value. Because it's numerical, we say it is quantitative. Still qualitative or quantitative. Audience ratings of a film on a scale of 1 to 5. Where 5 means excellent. This one is a little bit tricky, maybe. I would lean towards quantitative, but it's kind of like it makes you almost posit, could it be qualitative, because it's not really like a measurement, it's like a feeling. But I suppose we would still call this quantitative because the measurements are still numerical. Yeah, okay, subjective opinion. So again, it's wishy-washy on that one, so it's not really measuring any physical object. Since it's a feeling, that this would be qualitative, even though they're actually numbers. It's not a real measurement. Okay, fair enough. So consider the following 20 scores from a 100-point exam. Determine the appropriate bins and make a frequency table, including for relative and cumulative frequency. So maybe it'd be helpful if I actually wrote some of this out. Okay, so in this data set, it says consider the following 20 scores from a 100-point exam and determine the appropriate bins and make a frequency table. So for relative and cumulative frequency. So I'll show you how I would do it by hand if I had to. The one thing it doesn't mention is it doesn't give you the intervals, lengths. So I'll use what they're going to use for the problem, but a lot of times if it's your data and you want to group it in a typical way, say on a 10-point scale just for grades, ABC and so forth, you can do it that way, or whatever's to your liking. That part is a little bit subjective. They use a 5-point scale here, so if you look, basically the lowest score is pretty close to 70. So basically we've got our bin. That's a little bit, maybe I can make that a little bit smaller. So let's see, let's try again. We've got our bin, and then typically I would have like the tally mark, because as I would go through, I would just do it that way. Then I would figure out my frequency. And they want relative and cumulative. So we could do the relative frequency and then the cumulative. So let's figure out how that's going to go. So cumulative frequency. Okay, so that's our top row, let's say. And then the bin, so if we start from the bottom, we would start at 70 to 74, and then the top, there's no score. Well, let's start from the bottom and see if we can get that. So 70 to 74, notice that has 5 numbers, because you would count 0. 0 through 4 is 5 numbers. 0, 1, 2, 3, 4. And then we would go 75 through 79. Since these are all integer values, we can kind of work that way. And then go 80 through 84, 85 through 89, 90 through 94, and then 95 through 99. So I have a big gap here. But anyway, as we go through from left to right, we can just make tally marks. So 76 falls in this category. 80 falls in this category. 78 falls in this category. 76 follows in the same category. 94 is in the second category. 75 again is in this category. 98 is in the top. 77 again right here, so we're at 5. 84 is going to be here. 88, one above it. 81 down here. 72 at the bottom. 91 here. 72 again at the bottom. What was my 72 was my last one. 74 is also going to be here. So a lot of times if I were actually doing this, I would actually cross them out. So just make sure I didn't mess up that last one. So going through, 72 is the last one I marked. So we had a 76, 80, 78. So 72 and 72. Oh, and then 74 was the third marking. Okay, gotcha. So that's 3. So 86 up here. 79 again here. 88, third one. 72 bottom, and 75 here. As I said, I can't write on the PowerPoint, but if I could, I would probably cross off just as I went through one by one so I wouldn't mess it up. So the frequency, we've got 1 count, 2 count, 3, 7, and 4. So that's your frequency right there. Let me move down a bit. So our total is going to be helpful for the relative frequency. So if we add all those up, we have 3, 6, 9, 16, 4. So that's 20. So that's nice because 20s are easy to do percentages. So 1 over 20, that would be the first relative frequency. So that is 5% or 0.05. 2 out of 20, that's 10%. 3 out of 20 is 15%, or 0.15. Again, 3 out of 20 once more, so 15%. 7 out of 20, 35%. And then 4 out of 20 is 20%. And then to get to the cumulative frequency, again, that's the running total. So if we start from the top row, the total is 1. And then the next one we do 1 plus 2. So that's 3. And then we go 3 plus our next category 3. That adds up to 6. And then 6 plus the next category 3 is 9. And then 9 plus 7 makes 16. And then 16 plus 4 makes 20. And again, notice your very last cumulative frequency is in fact the total of all the data that we've observed. So let's go ahead and look at our next slide and see if we got all our answers. Yeah, so we have all the right percentages there, 5, 10, 15, 35, and 20, and then the cumulative frequency matches as well. So the only thing they left off is kind of like the tally marks. That helps you organize it if you're ever doing this by hand. So let's go ahead and move on. So moving on from this slide, bar and pie graphs. Again, these are typically things that are associated with qualitative data. Bar graphs basically show a count of each thing in a category visually. Typically there's a gap between them, as opposed to a histogram, which represents quantitative data. And you don't have gaps because the intervals typically abut one another. And pie graphs, basically they are useful to show the number of things as a percentage of the whole for qualitative data, excuse me. Yeah. Relative frequencies, yeah, you could do it that way as well. So yeah, the size of each wedge is proportional to whatever percentage of the pie, the circle, and that if you add them all together, that must total 100%. Okay, so if we look at the frequency here, we've got, like I said, qualitative data. So we've got, based on the grades, the frequency of each one, and then notice how there's gaps because we're representing qualitative data. And then you've got on the y-axis just your count, and the bar is just representing the height of each count. So the y value corresponding to the top of A is 4, which matches the frequency. For B, the top matches the y value 7, which is the frequency, and so on. They also made a secondary way to do the y-axis based on the relative frequency, which they don't have in the table up here, but we saw how to get it, right? The relative frequency for A would be 4 over 25, for B, 7 over 25, C, 9 over 25, D, 3 over 25, and D, 2 over 25, and as a decimal, you can figure out the percentages. So in the pie chart, you see them all represented here. So you can see that like C is the biggest piece of the pie, and B is a little more than a quarter, and F is the smallest percentage. But you actually don't have the frequency if you're looking at a pie graph alone based on percentage. You wouldn't actually know the total count, so you wouldn't be able to recover that because there's many different proportions that could represent. Okay, labels for graphs. So the title, caption. Again, this is often important to do when you're working with a resource like Excel. You want to make sure you're labeling things and that they're appropriate. Include them. A lot of times people will just go to the chart wizard, add a chart, and then forget to add appropriate titles. So that's important to do. And then you've got the scale. So the scale is something that you want to have make sense based on the data. And again, you mark those. Those are on the y-axis, and you have tick marks, and they should be clearly labeled so you can see the step between each tick mark. And then often on these, you'll have a y-axis title and an x-axis title. In the previous slide, the y-axis title was just the cumulative, not the cumulative, just the total frequency, and the x-axis was just the category, or the grade, if you will. Again, you should indicate the horizontal scale and title. So tick marks are not necessary for qualitative data, but they should be used with quantitative data, and typically that's going to be a histogram. So we'll talk about that shortly. A legend, if you have multiple data sets on a single graph, you want to have a legend to identify, what different colors represent or something like that. You may have two different sets of bars, one being red, one being blue. One is representing some subgroup and its frequency, and another one may be a different group. Maybe you're comparing, I don't know, classes of salaries of, say, like lawyers versus doctors. So you could have those two categories. So the histogram that I've already mentioned, this is a bar graph, but a lot of people don't like to use the word bar graph because there are some differences. But basically, the categories are created with bins based on quantitative data, and they have natural order. The bar widths have a specific meaning, and typically they're consistent based on the length of the interval. And a lot of times, every histogram I see typically, there's no space between the bars. They abut each other. A line chart, basically, if you had like a bar graph and you just connected the very tops of all the different bars with a line, that would kind of show the dot. So the dot is the center position in the center of the bin that's at the top of the bar with each respective thing. So you're kind of just getting a connected deal. So we'll see an example of that. Time series, you might be looking at the same data just based on year. So you could be looking at, say, I don't know, gross domestic product of the United States from year to year. And so your bars would actually represent not different categories, but things coming from different times. Okay, so essentially you see the what's going on here. They're just connecting the origin to the top of this line right here. To the middle of this line, to the middle of this line, middle of this bar, and so on. And notice how the histogram, there's no spaces between. This is basically saying 4 of the test scores were from 70 to 74, if 75 is included in this one. And then in this one, 7 from 75 to 79. This is basically just the frequency table that we did earlier. Here's a frequency table that's already done for us. And basically, we want to make a histogram and a line chart to display the data. So, I don't know. The numbers are pretty big here. I haven't looked at what scale they use. I would guess maybe on the y-axis, you would go in jumps of 5 if you were doing it by hand. A lot of times, you can represent this really easy on Excel. Maybe I can show you how to do that quickly. Well, I'll come back to it at the end. How about that? Yeah. So anyway, so they're organized in 10-year bins, and then histogram and a line chart. Once you have the histogram, you can make the line chart. And then they're doing some cursory analysis here that you can see that most actresses win the award at a younger age than perhaps male actors. So yeah. Yeah, and again, there's a belief that perhaps this is some sort of a bias towards older women actors. But okay, so there's that. So that is the chart. Let's go ahead and go back and see how we could construct this on Excel, because that's pretty useful. Or you could also do it on Google Charts, and it's pretty similar. So if we go ahead and let's see, let me see if Excel is still running on this thing. Okay, basically what we want to do is we just want to create our categories. We can just copy down all the data, number, and then, okay, so 20-29, 30/39, 40/49, and we're just typing it all in. I'll go ahead and pause the video so you don't have to watch all this. At least I'll attempt to. Okay, so now we have all the data entered here, and basically what you do is you just go to Insert, and you have recommended charts, and there's a bunch. So if you want the line graph that we did, you could go to a lot of times they're all under recommended charts. Oh, so you have to select the data, sorry. So if we select our data here, I wonder if we do this, if it'll actually label our axes, kind of. We'll see. So if you go to all charts, it'll have a bunch of different ones. So if you go to recommended charts, you can see all the charts that they have. And we could look for the line chart. That's the best represented one that we see right here. And it has it based on all the different numbers. There was a problem. I was having some trouble with histogram because it was not doing the bin size correctly. So there's probably something you have to do to edit that. But you could also just look at like a bar graph, and there's some representative ones where they're all next to each other. So that's pretty much the same thing. Anyway, so like say we wanted to do the line, you would just select that one, then say okay, and then it appears, and you'd want to change your like labels here. So this would be, sorry, let's insert that again. I didn't edit it. So we have our data. So age was here. So highlight everything. We'll do recommended charts. We want to do all charts. Line. Select this one. Then hit OK. And then you want to make sure you're inside there before you change it. And we could say, Oscar winning female age. And then for some of the other titles, you might have to click the plus and then add axis titles like this. And then, you could go ahead and go from there. Whoops. Somehow I didn't navigate that appropriately. Anyway, I wanted to edit it. The up arrow. So here we'll put the number is displayed on this axis and on this axis. We would have the age. So we can create a beautiful chart like that in Excel very quickly. All right, so let's go back and look at the last couple slides. Okay, so we get something pretty similar. So this one is a time series graph. So this is showing homicide rates in the United States. So this is the number of homicides per 100,000 people annually. So basically we see the gap here is by 2. So these gaps are all even, and you see this little break between 0 and 4 to indicate that that is not indicative of the gap between the tick marks, because none of the numbers are falling in that range. And they're basically showing the data every year, and the tick marks on the x-axis are every 2 years. But that's an indicator of time series data. So you're looking at the same statistic just over a number of years. And that's a line chart for those rates. So analyzing it, the graph shows how the homicide rate between 100,000 people has changed since 1960. It rose dramatically, more than doubling from a minimum around 62 to a peak around 74, and then remained high with some variations from about 93. In 93, it fell dramatically to the year 2000, then stayed nearly constant. And then here's a conjecture. The decrease in the homicide rate during the 90s has been attributed to tougher enforcement of drug laws and a crackdown on gangs. There's a interesting book by Stephen Levitt that suggests perhaps it was due to another reason, and it was fairly controversial, but if you ever want to have a look, that's an interesting book. It's called Freakonomics. It was a good read. Anyhow, you can use data like this to support your arguments based on historical events and changes in policy, and that's essentially what they're trying to do here. But that doesn't necessarily, indicate that it's valid. It just happens to be correlated. All right, well, that's it for this section.